In this video, we'll generate the trendline and polynomial of 1 over 1 minus x and its infinite product series expansion. We begin with the dataset of the 1 over 1 minus x array formula. We begin with 1 minus x and we continue, that's 1 over. So this is 1 over 1 minus x. And we chart this. Insert chart. And we use scatter chart. Row 1 as header. And show the trend line. Under series, hit the trend line. The type, polynomial. The degree, 8. For the label, use the equation. So here's our trend line and polynomial of 1 over 1 minus x. Next, we continue with the expansion, the infinite product expansion. To do that, we enter this is pi. It is pi, where n is from 1 to infinity of the exponent e to the power x to the power n over n, where the value of n is from 1 to infinity. 10 is good enough. Now we complete the array. So this is array formula. Exponent. That's for the value of e, the Euler's number. That is the quantity x to the power n. So x raised to the power n. That's x to the power n divided by n. And enter. Now we continue with the infinite product. So this is equal to product from 1 to 10. And we drag this downward. We copy this and drag this downward. So here you have the polynomials, the dataset. But we need the polynomial for this, so we edit the chart and show the trend line. Series, trend line, the type also polynomial, the degree 8, and for the label use the equation. So let's compare our expansion with the function. So they're almost the same. There's an error, but they're almost the same. They're perfectly same here, but there's already an error. And the polynomials. So coefficient of x to the 0, 1. Coefficient of x, 0.992, 0.994. Coefficient of x squared, 0.992, 0.995. Coefficient of x cubed, 1.27, 1.19. Coefficient of x to the fourth, 1.27, 1.18. Coefficient of x to the fifth, minus 1.08, minus 0.488. So there's an error. Coefficient of x to the sixth, minus 1.88, minus 0.383. And coefficient of x to the seventh, 5.38, 4.29. And coefficient of x to the eighth, 5.38, 4.08. So this completes the use of infinite product series expansion to approximate this simple pole 1 over 1 minus x.